Since the dawn of man, humankind has wondered about the origin of the universe we reside in. This has been attempted to be answered through a theory titled the Big Bang, coined by Fred Hall in the early 19th century.
However, what exactly is the Big Bang?
And how does this impact the age of the universe?
I'm your host, Bass Grills, and this is Science!
Our universe is said to have started off as a small singularity of immense density and temperature.
However, a huge explosion occurred, setting the small singularity into motion, causing it to continuously expand, which is still happening today. This event was titled the Big Bang.
And our story begins in the year 1929, California, where the scientist Edwin Powell Hubble was collecting data of distant galaxies. It was here he made the fundamental discovery of which changed the world's view of the Big Bang forever. By using a 100-inch telescope, Hubble was able to calculate redshift and velocity of galaxies, using his collected data of spectra and distance. He later proposed the universe is in continuous expansion. Now, let me explain what redshift is. Redshift is a term used to describe when an astronomical object has been observed to be moving away from the viewer, so that features in the object spectrum appear as they have been shifted to longer wavelengths. What does this mean? Well, due to Doppler's effect, when observing an object in motion, depending on whether it's moving towards or away from the viewer, the radiation's wavelength coming from the object is shifted. So if it is heading towards us, the wavelength will appear shorter. This is called blue shift. If it is heading away from us, it will appear to be longer or stretched. This is called redshift. So how does all this relate to the Big Bang? Well, by using Hubble's data, scientists can create a visual representation of the expansion of the universe, which can be used to support the theory of the age of the universe. By using Hubble's calculations of redshift, scientists can calculate that our universe is approximately 13.8 billion years old.
After studying the aforementioned redshift of various galaxies, Hubble discovered the rate at which the universe is expanding at, now known as Hubble's constant. This value is estimated to be at around 74 kilometers per second per distant megaparsec. He also found an interesting phenomenon in which objects that are further away appear to be moving proportionally faster than relatively closer objects. Let's examine this concept further by looking at a loaf of raisin bread. Imagine these dots are raisins in some uncooked dough. Let's pretend that we are raisin A. Raisin B is 1 centimeter away from us, with raisin C being further apart at 3. Now when the loaf expands, the distance between raisins doubles, with the raisins remaining at the same size. We are now 2 and 6 centimeters away from raisins B and C respectively. Note how raisin C appears to have moved 3 centimeters, with raisin B moving a mere centimeter. Since they have both moved these distances in roughly the same amount of time, raisin C appears to have moved faster than raisin B. However, if we look at this from the perspective of raisin B, we can see that raisin A would have appeared to move furthest. If we look at this from various other perspectives, we can see that the raisin that moves the shortest and furthest changes every time. In summary, Hubble discovered the universe was expanding at a rate of around 74 kilometers per second per distant megaparsec, which is now known as Hubble's constant. He also found that objects that are further away appear to be travelling faster than others, a term which is now coined as Hubble's law. Hubble's law proves that the universe is continually expanding at a constant rate, which in turn provides evidence for the Big Bang.
After this fundamental discovery by Hubble, evidence into the Big Bang remained sparse for a while. However, this changed when scientists Arno Penzias and Robert Wilson made a discovery which revolutionized the Big Bang in 1965. This evidence was titled Cosmic Microwave Background Radiation, better known as CMB. CMB is an electromagnetic radiation which is currently received as radio waves. It is detected by scanning the visible universe and therefore looking back in time, dating back to over 370,000 years after the Big Bang. Cosmologists can't see beyond this spectrum, because the universe was simply too hot before this time, creating this opaque plasma. This insane amount of energy disallowed photons to travel freely, and atoms were completely non-existent at the time. As the universe expanded, its temperature dropped to about 2,700 degrees Celsius. This was known as the recombination era, since it allowed electrons and protons to combine to create the first hydrogen atoms. This resulted in the emission of photons, which is the CMB recorded today. Thanks to CMB's discovery, NASA has been able to estimate the age of the universe at 13.8 billion years through the WMAP mission. CMB's discovery has also helped prove there was radiation left over after the Big Bang, as suggested earlier by cosmologists. CMB's recorded today has traveled approximately 13.8 billion years. Throughout this time, the wavelengths have redshifted to become radio waves. The reason why the temperature of CMB is no longer 2,700 degrees, but rather negative 270.425 degrees Celsius. Thus, the discovery of CMB not only provided evidence for the Big Bang, but the theory of redshift as well.
We owe our thanks to cosmologists such as Edwin Powell Hubble, Arno Penzias, and Robert Wilson, who attempted to answer what was deemed unanswerable about the origin and age of the universe.
However, countless questions still remain unanswered, awaiting future discovery. May the